Seven quadratic functions. We've done lots of work on this already. I asked you to go back and refer to your notes in section 2.2. Here's a summary of everything we know about quadratics, firstly in turning point form, but also in the expanded form. So I'll let you look at that yourself. Let's look at an example. So we've got a problem here. The graph of y equals x squared, so that's just your basic parabola, is stretched vertically by a factor of 3, translated 2 units right and 4 units up. We need to work out what that new equation is going to be, and we have to sketch the graph showing all the important features. So firstly, stretch vertically by a factor of 3. So here what the effect is going to be is on the y values. Every y value will be multiplied by 3. So the general rule y equals x squared is going to become this. Y equals 3 lots of x squared. Notice I've just put this x in a bracket, and you'll see why in our next step. We then translated 2 units right. So I've got the y equals 3 lots of x squared is going to become y equaling 3 lots of the bracket x minus 2 squared. Remember, we do the opposite. So here that's a move in the positive direction. So inside the bracket here I've got minus 2. Remember, think of it the other way. What would the translation be? I need to take whatever's in the brackets, make it equal to 0, and solve for x. And if I did that, you would get x equaling 2. That is 2 units to the right. So you know that this makes sense. And finally, we're translated 4 units up. So I take this and I just simply add a 4 onto it. So what was the equation y equals x squared, undergoing these 3 transformations described in the question, will become y equals 3 lots of x minus 2 squared plus 4. Let's consider the basic shape. The value in front here is positive 3. So because it's positive, I know it's going to be an upright parabola. X-intercepts. Our process is to make y equal to 0 and solve for x. If we do that, the logic is all good, except for we end up taking the square root of a negative number here, and of course that will have no solutions. Now this is sensible. We know that we've got an upright parabola, and we also know that we have the equation in turning point form. So the turning point here is going to be 2, 4, and it's upright. So it's impossible for us to have a graph that's going to go through the x-axis at all, because we've got 2, 4, and it's upright, so all the values are going to be greater than that. So this ends up being a minimum turning point. Y-intercept, just make x equal to 0 and solve for y. I get the position 0, 16, so that's given here. Here's the turning point, drawn in, done.